All right, hello everyone, welcome. Welcome. It's been a couple of weeks since we've been here chatting, so wanted to start today off just kind of giving you an update on where we are in the course, kind of what to expect for the next couple of weeks. We're kind of back in our regular rhythm for the next few weeks of introducing new material on Mondays, doing a studio on Wednesday or Thursday, and then submitting an assignment the following week. We've got 3 more weeks of that before our next exam comes up. So no exams in this class, at least for a little bit. On that note, the exam regrades have all been finished, and you should have gotten those back. In fact, exam grades should be on Canvas. And furthermore, I submitted midterm grades to the school, so you should be able to, it's exactly what you see on Canvas. There's no difference between the midterm grade that I submitted and the current grade that you see on Canvas. So just wanted to make you aware that all of that has been done. The other thing that I kind of want to point out is that this stretch that we're in right now, 5, 6, 7, is, it all kind of starts building off of each other quite a bit at this point in time. So much so that, next week when we talk about the Module 6 topic of recursion, we can't even really have that conversation without understanding what we're going to be talking about today, which is methods. And that's kind of going to keep happening as we move along. It's going to be very dependent on you knowing the material from past weeks in order to understand the material that's coming up in future weeks. So that's kind of one thing I like to remind students of. One tip I like to give people, if you find yourself struggling, it actually might be a better use of your time to go back a little bit and review those past concepts, because it all starts building off of each other quite a bit at this point in the semester. So just want to make sure you're all aware of that. We do have the Quick Flicker assignment coming up that's due in your lab this week. Can't wait to see how those turn out. And I think that's it as far as course announcements go. Does anybody have any questions or anything they would like to ask about before I hop into today's material? All right. Fantastic. So today is actually a very, very important topic. I'm really excited to talk to you about it. In fact, I'm going to kind of try to set the stage a little bit of what we're talking about before I hop into the code. What we're talking about today is something called methods. And what we're really trying to accomplish with methods is an abstraction. I'm trying to make, and that's a very technical term, right? I'm trying to take something and I'm trying to make an abstraction out of it, which means that, instead of having to tell you these 10 steps over and over and over and over and over again, I will tell you how to do those 10 steps one time and then reuse that chunk of code over and over and over and over again. That's kind of the goal that we're getting to. And to give you a better idea of what I'm understanding, or what I'm trying to talk about, I want to introduce a concept which you are hopefully already familiar with, or maybe understand. Cooking actually has a boatload of abstractions in it. You've probably never thought about it this way before, but it's absolutely true. I love cooking. I do almost all of the cooking in my house. I'm a big fan of making tasty food. But any time that you're asked to follow a recipe, you're going to see words in there like saute. You're going to see words in there like grill, right? And so what does it mean to do those things? Well, grilling, obviously, is when you get some heat source underneath a grill top with the grates so that stuff can fall through. And I'm explaining stuff that you already know, but think about what those recipes would look like without any abstraction. I would literally have to say at the beginning of every recipe, get out some coals or some other heat source, put them into a container, put a grill cover on top of that container, light the heat source so that it gets hot, and then you can finally put whatever food you want to on top of that surface. We don't say that in recipes, right? That's redundant. What do we say in recipes? We say grill. We say grill the vegetables, grill the meat, grill whatever the heck it is that you're grilling. And then what comes out after we do that is tasty food. And that's kind of what we're getting to with our code as well. We don't want to have to be redundant in our steps. If there's something that I have to do a whole bunch of times, which is common, right? It's very common to have to be repetitive in our code. Instead of saying those steps over and over and over again, methods provide us a technique to abstract that concept out so that I can say what those steps are one time and then repeat those steps over and over and over again by referring back to that one piece of code that's been written out. So it's a very, very, very powerful technique, and it's going to fundamentally change the way that we look at code. I say that because up until now, every single example that we've seen in this class has started at main. Actually, we can be more complete today, since we're talking about methods. This is called the main method. So this is a method. We've actually been using at least one method this entire time called the main method. But you may have noticed I kind of glossed over this part right here. This is another method. This is a second method, right? So up until today, we're used to starting at main and just going top to bottom, right? Just like reading a book, kind of. That's not going to be true anymore. We're going to be using these abstractions, which means we're going to be referring back to the same piece of code over and over and over again. That's what methods allow us to do. And so instead of moving down main top to bottom, we're going to have to jump. We're going to have to jump around. And actually, this first line illustrates that fact right away. It says chorus, where chorus is the name of this method right up here. I'm going to talk to you a little bit about the structure of methods, and we're actually going to learn what this whole chunk of code means today, as part of today. But for now, I just kind of want to get you used to the flow of this program, the flow that we're going to be kind of working with now that methods are in play here. So what I'm going to do is I'm going to set a breakpoint here at line 15 in my main method. The main method is still where we start. That is still our starting point. That is kind of why the main method is important. The main method is the entry point, the beginning of our program. So if I want to know the first line to get executed, it's actually not this one, right? That might be a little surprising. It's not the top line that you see anymore. The first line of code that gets executed, it could be this first line if main happens to come first, if the main method happens to come first in the file, but it could be farther down. It's just whatever the first line of main is. So this will be the first line that gets executed. I'm going to run this through the debugger and show you what happens when we use methods in our code. Here I am on line 15. Over here on the left is actually a part of the debugger that I have not shown you today until today, but today is a great time to talk about it. This is what's called the stack. And it's called the stack for a reason. It's quite literally thought of as like a stack of plates or a stack of papers, right? However you want to think about it. The idea behind a stack is if I put something on top of the stack, that is going to be the first thing that I'm able to take off the top of the stack, right? So you'll learn more about stacks in a lot more detail if you move on to take data structures class like CSE131. But what this is doing for us today is tracking our path through the program. So I just mentioned how we're not going to be running straight through anymore, top to bottom. We're going to be jumping around. We're going to be jumping to other parts of the code, and then we're going to be jumping back. And we're going to jump to another part of the code, and then we're going to jump back. How does the computer keep all that straight? How does the computer know where to go next? How does the computer know where to jump to and how to jump back? That's what this is for. That's what this stack is for. So if you're ever kind of interested in your current position of within the program, the stack can help you out with this. And so if we take a look at the first line of code here, it's actually doing something right away that says, go find the piece of code that we have called chorus. And do that stuff. So this is a name, right? Just like we've had variable names, this is now the name, not of a variable, but of a method. And so when I see the name of the method written out like this, this is a term we would use to describe this as a method call. I am calling the method. I am saying, go find the method called chorus and do whatever it says to do. So actually the next line that I expect to execute is not line 16. Before today, that would have been true, right? But today we're dealing with methods. The next line of code that I expect to execute is actually up here in the chorus method. line number 10. That's what this is telling me to do. It's saying jump up here and do this stuff. And I can show that to you in the debugger. I'm going to introduce another nice feature of the debugger for you today. Before, we've been using this guy, step over. And I still am a big fan of step over. We're not going to stop using step over. But this one right next to it is called step into. And it is specifically used with methods. This part of the debugger, step into, is used when I'm interested in understanding methods. So if I click step over, it'll actually move down to line 16 after doing all of this stuff. If I click step into, it says I want to actually go to that method called chorus. So here I am on line 10. That'll get printed out. Oh, whoops, I did not mean to click the step into button. Sorry about that. I meant to click step over. There we go. That line will get printed out. The next line will get printed out. And now the chorus method has done what it's been tasked with, right? It only has 2 print lines in it. They got printed. The chorus method is over, so the question is, where do we go next? And the answer is we return. When a method is over, we say that method returns. And we mean that quite literally. Where do I return to? I return to where that method was called. I return to where that method was kicked off. And if you want to get even more specific about it, where do we return to? How does the computer know where to return to? Well, look at the stack over here, right? The stack is saying, hey, we started in main, then you told us to go to chorus. When chorus is finished, when chorus is ready to return, where am I going to go back to? I'm going to go back to main line number 15, because that's where I came from. So the stack is remembering where we are at every step along the way. Whenever the method that I'm in now is over, I just go back to wherever I was before. So which method is always going to be on the bottom of this? The method on the bottom of the stack is always main, every time. I know that the method on the bottom of the stack is going to be main because main is the starting point of all of my programs. Main is where my programs begin. Yes?
And so, would that imply that you can have multiple of those other methods inside of the column throughout the whole thing, or
No. So we are not limited to the number of methods. It's a great question. We're keeping things simple, right? We're going to introduce more and more stuff as time goes on. But yeah, we're not limited to the number of methods. In this file, I just have 2. I have main and I have chorus. Once we get to making some bigger, more substantial programs, I'll have maybe 10 or 20 methods in a file. That's not unusual. And so then think about what that means, right? That means that I'm going to be jumping down to all of those 10 or 20 different spaces at some point in time and jumping back. And it gets even more complicated than that, because I don't always have to go to a method and then go back to main. I might go to one method and then go to another method and then go to another method and then go back and then go to another one and then go back and then go back again, right? So there's a lot of different combinations that can occur, which is why it's not so important necessarily to understand exactly how these specific programs work as much as it is to understand how the methods work, right? If you understand this idea of jumping to where a method is, right, and then returning to where it was called, you can decipher any program that uses methods in this way. So yeah, if we continue on with this example, since this method is over, it's about to return, it's going to jump back to where we left off. So line 15 is what told us to go up there in the first place, and then once that is finished, we jump back and we continue on with the rest of our program. Okay? So what's interesting or perhaps useful about methods, I want to try and motivate why this is so important, because a lot of times students will think that this is just making things complicated with, what's the advantage, right? Yes, this is more complicated. That is true. Yes, this does make things more complicated. What's the advantage? Consider that this is a very simple program, right? I'm just printing out a simple little song. But let's say I had a mistake in this, like I'm misspelling or something, right? I just accidentally a word or something like that. If I didn't use methods, then I'm just sitting here and I'm copy pasting this anytime I need the chorus, right? I'm just going to copy paste this code. This is the opposite of using methods. This is not abstraction. This is what I'm hopefully trying to convince you is not what we want to do today, right? So consider that if I have a song where the chorus pops up 5 times and I have a typo in my chorus, I've just copy pasted that typo 5 times. Right? I've taken that mistake and I've propagated it. I've made it worse. It's now showing up in many different places throughout my code. Think about how that changes if we use abstraction properly. I'm recognized that there's repetition here, right? So instead of having this code copied over and over and over again, we'll have it just written down one time at the very beginning, and then we use this method call anytime we wish to refer to that code. So just like we had at the beginning, if I want that chorus to repeat again at the end of the song, all I have to do in the code is say, hey, go do the chorus again. And it will jump back up to the top and do the chorus again. In fact, that's so important that I think it's worth showing that to you, right? Here I am on line 15. I step in and I run through chorus the first time, do the middle part of the song. Then I get to the end of the song and I'm going to step up. It jumps back up to the top and it's going to run through chorus a second time. So back to this idea of how is this helpful? Now if there's a typo, if I make a mistake somewhere in my code, I only have to go one place to fix it. If I change how this works here, if I change this word here, anywhere that I have said to use that code, it's going to show up. Right? That's abstraction. That is the concept of abstraction. Taking an idea and not writing it out every single time I need to use it, but writing it down once and then referring back to that one time that I've written it down over and over and over again. That's what we're doing today. Everything else I talk to you about today is going to be a variation on that very important workflow. Does anybody have any questions for me so far? We got lots more to talk about, but does anybody have any questions? Anybody confused about where we're at the moment? Yes? Is the what method defined by the? Oh yeah, that's a great question. That's a great question. I mean, this is a method that I didn't personally write this, but somebody wrote this, right? Somebody wrote this method. The computer didn't make this up. This is somebody chose to make this. And normally that's going to be you as the programmer to recognize that, hey, this is an operation that I'm going to want to do a bunch of times. I'm going to write a method for that. That's our job as programmers. We'll see lots more examples of that as we go through today. Great question. All right, I'm going to switch out of the debugger for now, although we'll probably be back to it a little bit later. No, I don't want to do that example. I do want to do this example. So let's talk about, actually this is kind of similar to the question that was just asked. Let's talk about this for a second. This is what's known as the method signature, or the method header, you might hear it referred to, method declaration. This line of code describes very important information about what this method is going to be doing for us. So the first word, public, actually the first two words, public and static. Public has a complementary word, private. We're not going to see that word for another couple of weeks. For now, we're just going to live in the public realm of things. But making things private is a thing that we can do. It's not really important for us to talk about today. We'll talk about it later when we need to. Static, the contrasting complementary word for static is just non-static, or if you can actually just leave this off. Static is optional. However, for this week and for next week and for exam 2, actually, that's important for you to know as well. all of the methods that we're going to be working on are going to be public and static. So that will change. We'll eventually show you other forms of methods that aren't public and other forms of methods that aren't static. But for the next couple of weeks at least, we're going to keep things public and static. This next part of the definition, that's what's known as the return type. So that'll be something that we talk about in a few examples from now when we get down to this part, get down to this section. If the return type is given as void, that means that there isn't a return type. Or you can think of the return type as the output. So to refer back to my cooking example, right? If I'm grilling, something, then the output after I apply that method is warm food, right? So for a grill method, I would want to represent that somehow. But for, we'll talk about return types in more detail later on. This is the name of the method. This is important because anytime I want to use this, I have to specify what the name is. This name should be descriptive. So variables are another thing that I've talked about is needing really well-chosen names to describe the data. This, however, is not describing data. Methods are not things. Well, actually, methods are things. But what are methods doing for us? Methods are actions. Methods are things being performed. So the name of your method should not be a noun. It should be a verb. Actually, some of these examples are not following that rule, to be perfectly honest with you. But you should really be thinking about what your method can do, what your method is performing, what actions the method is performing for you. And then inside of the parentheses, these are going to be our inputs, or we call them parameters. These tweak how a method runs, right? These tweak how a method runs. Again, to refer back to our grilling example, if I had a grill method and I plugged in a steak, then I would get a grilled steak back out. If I plugged in some, vegetables, I would get grilled vegetables back out, right? So I can apply this method to different things, and depending on what these inputs are, that's going to have an effect on how the method behaves, on what the method does. So then if we take a look at this example, actually this example is a good one to show you how these input parameters can affect the execution of a method. We've got this classic kids song, Old MacDonald. To be honest, I have two little kids at home, and I'm so sick of this song. But it's definitely a classic, one that most people know very well. And the difference is when you sing the song, right? You've got different animals that make different noises. That's kind of what the song is about, what sounds different animals make. So instead of having to, again, think about what this would look like. I'm not going to do it for this one, but think about what this would look like if I wanted to write this song out for 3 different animals. I would have to copy this whole chunk, right? 3 different times, and then go in and swap out all of the different animal names and all of the different noises. That's very tedious and also very unnecessary. Instead, a good thing to get in the habit of doing, and one that I'm going to encourage you to think about as you're working on your code, is try to identify the repetitions. Try to identify where that code is being duplicated, put it into a method, and then use the inputs to tailor that. So instead of having to write out verse 1 for cow goes moo, and then verse 2 for duck goes quack, down here you can see that all that needs to happen is I say verse, plug in the animal, plug in the noise, and then it does the whole thing. In fact, I can show it to you. Right? Oh yeah, great track. Banger. If I want to add another verse, how easy is it? I just copy this method call and I plug in a new animal, right? And now I've expanded this code out to be 3 verses instead of 2. Again, contrast that with how you would have maybe tried that before, knowing about methods. You would have copied that whole chunk over again and then had to go in and replace the name of the animal and the noise everywhere. would be very tedious and not fun, right? So that's not how we want to program. That's not how we want to write our code. We want to use these methods to help us abstract these things out. And so let's take a look. I'm going to be using the debugger a lot today just because I think it's so important for people to get used to the flow of these programs with the method calls. Again, I start it on the first line of main. It says, go do a verse with cow and moo. And so if I step into this, take a look over here on the right. I see a variable called animal that's equal to cow and a noise that's equal to moo. And as I progress through this verse, you'll see that it's going to concatenate those variables in to the song as necessary, right? It refers to those parameters. I said variables, they're actually parameters. Notice that variables, parameters behave in much the same way, right? What are parameters? They're really just special variables that we use as inputs to our methods. That's what they are. So yeah, we run through the program the first time using our first set of inputs. And then once that's done, what's going to happen? Well, we're going to go back up to the top and we're going to do it again, but take a look at the variables this time around. Duck and quack are what's going to be substituted in. So when the method is called, this is a method called. Notice that I have to specify what the values of these parameters are. Animal and noise. However, notice that within this method itself, I don't actually specify that, right? You can think of these as kind of placeholders. I have no idea that this is eventually going to be cow or pig. That's just a placeholder that somebody's eventually going to plug in later on when they wish to use this method. So the method definition by itself, this chunk of code by itself, does not do anything until it is called. Right? I can write this code out, but it does not do anything until it is called. Here's something that happens a lot when students are working with methods. They'll write out a method. They think they got it working. They want to test it. They want to see if it's doing what what it's supposed to, and they'll forget to do this stuff down here. They'll just forget. It's an easy step to forget. If I take those method calls out and I try to run this program again, what's going to happen? Absolutely nothing. I never said, hey, go up and do the verse. I never said that. So if you can have this perfectly beautiful functional method. If you never call it, it's not going to get used. It's not going to be included as part of your program. So make sure that somewhere in your code, in the appropriate place, you actually call the method by plugging in the parameters. Another note about these parameters, we can have as many of them as we want. So you can see here it's just a list. It looks almost like I'm creating variables, right? Type followed by name, comma, type followed by name. And you can keep going. I would say that while there's no limit on this, if you start finding yourself writing methods with more than 3 input parameters, that would be a cause for me to pause and be like, am I trying to do too much here? Am I going a little bit overboard? Not to say that you'll never write methods that have more than 3, but it's definitely kind of the upper limit of what I would want. It's also very possible to have none. In fact, we saw that in our first example. This has no inputs, and when we called it, you can see there's nothing in the parentheses. The parentheses are still there though, and that's an important thing to remember. When we see these parentheses, that's an indication that I am calling a method. And so with that in mind, you can actually look at something like this, right? Oh, printline is a method. I've been using it all the time. Math.random has those parentheses on the end, right? That's a method that you've been using this whole time. The scanner stuff, right? next line, next double, all those have parentheses on the end. Those are methods. Very, very common. Very, very difficult to write any program that isn't going to have methods in it with the way we do coding these days. Let's take a look at some more examples and get some more practice in. Here's an example where we're going to kind of try and work in a different direction than what we've been doing so far. I'm hoping that if you look at this, you see the redundancy that we have here, right? I see two blocks of code that look very similar. They're calculating the weekly pay for two different employees. And you can imagine that, okay, yes, this could very easily be extended out to 5 employees or 100 employees if I work at a big company, right? So this is a chunk of code that may need to be done many different times. Right now, I would say it's not set up very well to do that. So let's write a method. Instead of having this same code copied out twice, what we want to do is we want to write a method and then use that method twice. That's good programming style. That's good abstraction. It's good use of abstraction. So we're going to create a method called calculatePay. All right, how do we do that? How do we make ourselves a brand new method? First off, I want to make it very clear. It's your decision when to add a new method into a program. It's your decision. Sometimes I'm going to tell you, make a method that does this, right? On the assignments I will, but that's not how the real world works. There's nobody telling me what methods to write in my code. I make the decisions on what methods to write in the code. I can add one whenever I feel that it is necessary. So don't feel like you need to ask permission. You don't. It's a tool that you have in your toolbox that you are free to use whenever you deem it necessary. But here, we know specifically we want to create a method called calculatePay. How do we do that? Well, we got to start with the sort of magic words, I guess. Public static. For now, those two words are always going to be the first part. That will change eventually, but for now, those two words are always going to be necessary. Now we have to decide on what the return type is, what the output is. We haven't actually talked about that yet, so we're going to stick with void, but I am going to show you some examples a little bit later on that do things a little bit differently. Next is the name. I want to call this calculatePay. And now we have to think about what the input parameters are. And to understand what those are, let's take a look at this chunk of code. I see which values are changing, right? I see that the name is changing, the hourly rate is changing, and the number of hours that they work are changing. So those are probably going to be my 3 input parameters. String employee. The next one would be double hourly rate. And then finally we'd have hours worked. It looks like an int. I mean, I feel like that one could be a double too, though, right? I feel like you could make an argument for hours worked being a double. If you really want to keep it int, that's not necessarily a problem for this example. Okay. So what does the code actually need to do? Well, it needs to compute the weekly pay. And then it needs to print out how much this person is getting. It basically needs to do these 2 lines right here. In fact, the nice thing about doing this abstraction is that I think I can just take these 2 lines, whoops, if I copy them properly, there they go. Copy them properly and just stick them right up here. I need to, why is this upset? What's missing? It's not declared, so I need to put a type out here. Once I fix that little error from copying, I think this is ready to go. I think this method is ready to go. However, keep in mind that this is just an abstraction. This doesn't do anything. This is a generalization. This is like me describing what the act of grilling is to someone. That's not the same as getting a piece of food out and slapping it on the grill, right? In order to do this, we have to call it. We have to call the method. So we're going to come back down here. These are the two chunks of code that I identified as being redundant and wanting to replace them. So let's replace them with a method call to calculate pay. The first parameter is the employee's name, so I'll plug in Fred. And I deleted the next two values. I should have remembered what they were. 12.50 and 20. Okay. 12.50 is the hourly rate. That's the second one. Notice that I'm taking care. The order matters, right? I can't just throw these in whatever order I want. The name has to come first. The hourly rate has to come second. And the number of hours worked has to come third, because that's the order that they appear here. So have to make sure that we're following that same order. 20 hours for this guy, right? And then we're going to do the same thing again down here. Amir, 15 and 35. Oops. And we can actually see that since we've replaced everything with these method calls, Eclipse is telling us that these are not used anymore. We might as well just get rid of them. If we really don't need them anymore, just get rid of them. And now look at that. Look at how much this code has been consolidated, cleaned up, condensed. To be fair, that won't always be the case. Sometimes the code will get bigger when you make changes like this. Making things smaller shouldn't be the goal. Making things more understandable, more efficient is the goal. So if we need to say a little bit more to make that happen, that's worth it. But I want to make another important point here. We did something that is such a common programming activity. I rewrote this code, but I did it in such a way that it works exactly the same as it did before I rewrote it. Right? I didn't want to change what the output looked like, right? I just wanted to change how it got there. We do this so often that we have a name for it. This is called refactoring. Refactoring is a term that we use when I'm trying to rewrite code. I wanted to do exactly the same thing as before. I'm just going to rewrite the code and do it a little bit differently for the purposes of organization, for the purposes of making the code easier to read, easier to understand, more efficient, right? It's a very, very common thing that we do as programmers. And so, now that we have done that refactoring, of course, the last step is to run the code and make sure that it's still doing a reasonable job, and it looks like it is. So it's jumping up to this calculate pay method twice, right? And from here, hopefully you can see how if I did have 100 employees, it would be easy for me to keep doing this. In fact, I could even go so far as to stick this into a for loop of sorts, right? And churn through it that way. That's another thing we can do if we want to. Any questions about this problem? Yes?
Yeah, so I know when you're calling it for Amir, I know 15 is the same as 15.0, but why would you not have to do that considering that it's made like the double?
Okay, so the question is, why didn't I have to type 15.0 in here? The answer is that 15 is still good enough as a double, and really because I've said that it's a double here, as soon as what is I mean, this is a good question, and one that I kind of showed you before, but is maybe worth talking about in a little bit more detail. What happens when we call this method? I'm quite literally taking this value and assigning it to this parameter, much like a variable assignment happens, right? That's what it means when I call the method. I take this value and I stick it in here. I take this value and I stick it in here. So because this is declared as a double, this doesn't really matter. It'll get converted to 15.0 once that assignment takes place. It's a great question. And you can, of course, see that in the debugger. Those values do very much get assigned to each of those parameters, just like I was talking about. Yep, great question. Any other questions before we move on to some other examples? Alrighty, great. Let's talk about a concept called scope. Scope is a very, very important concept. Some of you have already run into scope, actually. We could have talked about scope a little bit earlier. In fact, I feel like maybe, it kind of feels like maybe I did talk to, can't remember if it's this section or the next section about scope a little bit because somebody asked, but today is a great time to talk about scope. Scope refers to variables, and specifically the scope is when can I see a variable in the code, or when can I not see a variable in the code? Because it's possible, very, very, very possible to create create variables in my methods that have the same name. If I wanted to, I could actually come down as an example and create another variable called centimeters here and set it to some totally different value. There's nothing wrong with that, right? So which one am I going to use? If I refer to, like, if I look at this one here, am I going to use this copy of centimeters or am I going to use this copy of centimeters? That's kind of part of the question that we're getting at. The scope tells us that I'm going to use the one that is closest to me. So essentially what that means is I'm going to use the one that is inside the same set of curly brackets that I am. These curly brackets actually define the scope of a variable. What do I mean by that? I mean that if I create the variable inside of these curly brackets, that is where that variable can be seen and used. As soon as I leave these curly brackets, I cannot see that variable anymore. It's no longer accessible to me. So let me show you a more concrete example of that. If I start the debugger on the first line of the program, which is going to be line 15 down here, okay? I need to stop my last example and then start this one. Notice that if I look at my variables window out here, I don't see this variable, right? Because this variable does not exist inside of this method, inside of this scope. If I step into here, you can see, okay, it gets created and I print it out. But then when I go back to the main method again, do I see the variable called centimeters? I just saw it a second ago. We created it, we used it, but I don't see it because it does not exist inside of this method. Actually, where people see this before today, loops, if statements. You may have run into this, right? If I create a variable within a loop, I can only use that variable within that loop. As soon as I leave the loop, that variable doesn't exist anymore. That's scope. The scope of a variable is defined as the curly brackets, right, where it can be seen from. And so this is an important thing to talk about, right? It gives us isolation between our methods. I don't have to worry about my variables conflicting across methods. That's a nice thing. That is a good thing for me, right? But it also means as a programmer, I have to think very carefully about where I'm creating those variables. If I do have a variable in main, right, index equals 7, and I want to access that value of x up here for whatever reason, right, it's not going to let me do it. X doesn't exist inside of this scope. X doesn't exist inside of these curly brackets. It's down here. So then as the programmer, I have to think, all right, is that really the proper place for me to create X? Do I need to add an additional parameter for this value to this method if I really want to get access to it in there? Because the way we get around scope restrictions, if we want to, is by passing values in as parameters, right? Passing values in as parameters. That's how we get information into and also out of our methods, if we want to. Any questions about that? Any questions about scope? Scope of a variable, scope of a parameter. Actually, this one's a little bit, I almost forgot this one. The parameters are a little bit of a rule breaker. I've been defining scope as this whole time as what comes between the curly brackets. However, parameters are sort of an exception to that rule. they behave as though they were created inside of these curly brackets, right? Though you can see that technically they actually are outside of the curly brackets. But because they are the method parameters, they behave as though they are a variable that was created within that method. These parameters cannot be seen without outside of this method, just like any other variables that are created within it. Alrighty, how much time have I got? I got oh, okay, I got a good chunk of time left. That's great. This example is illustrating a concept known as call by value. So think about this. I have a method. I plug in a number. That method is then going to do something with that number. It's going to multiply, divide, whatever, right? Some arithmetic operator. Does that change this value? So you see the 5 gets plugged in, right? I square it. What is the value of y going to be after I do that? Is it going to be whatever the result of this computation is? Or is it going to remain its original value? Those are the two options that I see, right? I'm taking this value of 5, I'm plugging it in for the value of x, I'm squaring it. Well, let's run the code. Let's run the code and see what happens. All right, just run the code, please. So we walk through this step by step. I create my variable called y. I plug it into the method. I jump up here. X is 5. That's what I said. So now I say, all right, x is equal to 5 times 5. That's 25. And then I print it out. But then I return. I go back. And then I say, print out y again. Well, I just squared y, right? Just squared y in the previous line. But if I look at what happens when this gets printed, it says 5. So just because I manipulated some values up here in this other method, it does not affect the values of the method where I originally started from. This is the concept that is known as call by value. I mean, something else that I think makes this example a little bit more interesting. What if I do this? There's nothing wrong with this. But my question to you is, how many x's do I have? How many variables called x do I have? There's 2. There's 2. And I think that's important for understanding why making a change up here doesn't affect the value of x down here. When I make a method call, I am taking this value and I am putting a copy of it into this parameter. That's what call by value means. That means that I actually have 2 copies of x. So when I make this manipulation, I'm just manipulating one of the copies of x. The original copy of x that I have down here remains unchanged. And that's important for the continuity of this code, right? Think about how confusing it would be if I just ran through this code. I said x is 5, square x, and then I printed it out, and x is now 25. That's confusing. The value of x changed, and I'm not exactly sure how that happened. Call by value says that, oh, it's actually only going to change up here within the scope of this method. This value will retain its original value after the method is over. Again, might seem kind of subtle, might seem kind of nuanced, but getting used to these concepts is an important part of understanding how methods work. Any questions about call by value before we move on to return types? I'm going to skip this one. We're going to do return types next. All right, let's talk about this part of the method definition. Up until now, it's been void every time, which means there's no output. There's no return type. There's no return value, which means the method is not going to generate anything. It's not going to give us anything back. So in the past, or what we've seen with the methods we've been doing, they've been printing the values, right? But think about the limitations of that. In fact, we can just go back to our previous example to see some of the limitations of this. This prints out the value that is squared, but what if I actually want to use that, right? What if I need that number and I need to perform some additional computations on it? I have no way of accessing it. Here, let me show you what I mean with the debugger. I take my value of x, I plug it in, it says the answer is 25 and it prints it, but do I have a number 25 over here that I can access? No, I do not. I can't actually use this result. I can see it, right? But I can't take that result and then feed it into another computation. So the reason for that is because this return type is set to void. That means nothing is coming out. It even says up here, square returned nothing, no return value. So if I want the value, a value to get out of my method, if I want a value to be returned, I need to specify a return type. So here's an example of that. And look, the return type is just one of the types that we're familiar with. This one is saying that after I compute the volume of the cylinder, I'm going to output a double, and I'm assuming that that double represents the volume of the cylinder that was just computed, right? So what do I have to do? I have to plug in the radius and the height of my cylinder, and then it will output the volume as a double. That's what the return type is saying. This is not the same as printing. I want to make that 100% absolutely clear. In fact, you'll see there's no print statement in this method. Instead, I see this statement. Quite literally says the word return. So all methods return. I want to make that clear. Even the methods that don't explicitly say return, once they get to the closing bracket, they return. That's what they do automatically. You don't have to say it. It just happens, right? But if I have a return value, if I'm telling you, hey, I'm not just going to return, but I'm going to give you something, I'm going to give you an output, then I have to tell you what that output is. I have to say, here is the value. Here is the result. Here is the output. And again, I want to make that very clear that this value does not get printed, at least not right now. It is getting returned. So returning a value and printing a value are two very separate things, and I'm trying to make this point very clear because this is another classic topic that students get confused on, right? Printing is the act of showing something on the screen. Returning is the act of taking a piece of information and moving it to a different part of the program. So it does not involve displaying it on the screen at all. They're two totally different operations, right? Both useful. You can do them both in the same code if you want to, but they are two totally different operations. So to understand how this works in a little bit more detail, notice the print statement's down here. The volume that gets computed is not getting printed up here. It's getting printed down here after we get back. Let's run this one through the debugger to show you what's going on. Starting on line 15, that's the first line of my main method. Main method's where we begin. So let's run this through the debugger. I am here. All right, here I am on line 15. I'm going to go in, say, all right, there's my radius, there's my height. It's going to compute the volume for me. Now if I look up here, it says volume cylinder returned 502 dot something. Oh, hey, it's a double, right? It actually gave me a value. So what's it going to do with that value now? Well, look at this line. We haven't seen this before, but that's just a good old variable assignment. So it's taking the value that's been returned by this method and storing it into a variable. I would actually argue that you've probably already done this before. You've probably already taken a return value and stored it in a variable before, probably doing something like, something like this. Math.random is going to return a value between 1 and 0, and I'm going to stick that value into a variable. Right? That's another example of a method returning a value to us. But in this example, you can see that once that value gets returned, the variable gets created, and the value is now stored in that variable. And now I'm free to reuse this wherever I need to. I can pass it into another method, right? I can do more computations with it, or as we see here, I can just print it out, right? I want to make it absolutely, absolutely, absolutely clear though, and I know I'm pounding this point into the ground, but returning and printing are two different things. If I don't have any print statements in my code, right, then I'm not going to see anything down here at the bottom. But I can still return stuff. Returning has nothing to do with printing. Returning is just moving information around. Printing is displaying information on the screen. So yeah, make sure that you kind of have those two concepts distinguished in your head, hopefully. All right, let's take a look at some. Let's take a look at some more examples. Here's a great example of kind of what I hope to get away from, kind of what I hope that you won't do, which is here we're computing the value and we're printing it. We're printing it out right away, right? But then I can't access it from down here. So it's going to tell me what the centimeters value is, but if I want to do something with that later, let's say I wanted to add these two together. I can't do that. Let's say I wanted to convert these two measurements to centimeters and then sum them up. It's not possible right now. The way this code works, it computes those values and it prints them, but then I never get them back. They never actually come back to me. So the better thing to do is not print here, especially if you are using a return type. Whoops. There we go. I'm going to switch that from void to double. You can see that when I do that, Eclipse gets mad at me. It says, hey, you told me there was going to be a double that was output. But that's not happening right now. In order to make this happy, what do I have to do? What statement do I need to put in? It starts with an R? I have to say return. I have to return something. And to be clear, right, I can return any double here, but this is kind of a mean thing to do. I'm saying that every, no matter how many inches you give me, it's going to be half a centimeter. That's not very nice. That's not a very nice thing to do. Try and do the proper thing and return centimeters. All right, how does that change this line of code down here? Because right now, if I run this, you'll see that I took the print statement out, replaced it with the return, and now nothing gets printed. Well, what I can do down here, I need to capture that return value. In fact, right now, this return value of centimeters is being given to us right here, and I'm basically saying, oh, thanks, and then just chucking it out, throwing it in the trash. I have not made a variable to capture that return value. So I would make one that says 10 inches. I need a type, don't I? Double. And then I would make one that says double 12 and half. That's a long variable name, isn't it? And at this point in time, since I have captured the return types, the return values as variables, I can print them out, or I can sum them up, right? If I can spell, spelling is not my strong suit. As you can see, it looks like, there we go. All right. So this is the style that I really want you to get used to. Printing is okay, but don't overdo it. A lot of students will want to print this out and then return it. Oh, I mean, okay, not necessarily wrong, but you can definitely go overboard with the printing. We're going to be returning a lot more than printing from now on, I would say. Returning is a great way to move data around your program. So let's try this one down here. I got 20 minutes left. Perfect. Yeah, I definitely want to do this example, and we'll see if we have time to do another one after this one. This is a good kind of review of some stuff that we saw in the last section too. I want to write a method called random number in range. It's going to take in two integer parameters, min and max, and it's going to return a random integer value from within that range. So if I plug in, random number in range 5 and 10, I want to get a random number between 5 and 10. If I plug in, 50 and 100, I want to get a random number between 50 and 100. So let's do that. I want to create a method. First thing I need for now is public static. Next thing I need to do is decide on the return type. I'm generating random values. Specifically, it says I'm generating random integers. So I think using int is probably an appropriate return type. I have to give this a name. And then inside these parentheses, we have to specify what our input parameters are going to be. Thankfully, they make it somewhat straightforward for us. Tell us we need two integers, one called min and one called max. Then we put our brackets. And at this point, we're really just using that formula, that same random number formula that we've already gone over in class from, I don't remember what week that was, week 2 maybe. So I'm not gonna talk about that in tons and tons of detail today, since I'm assuming it's kind of review. We're gonna multiply by, I might wanna break this up though. Let's compute the range, min minus max. And then we're gonna add the min. And then I need to probably put that into a variable. And then finally, I need to return that array. What's this gonna do when I click this button right here? Okay. Yeah.
It's not going to print anything.
It's not going to do anything. Why not?
There's nothing happening in main.
There's nothing happening in main. Main is the first step of our program. Main is where we begin every time. So if you want to know what the first line of code is, go find main and look at what's in there. And right now I see there's nothing. There's nothing here. So what's going to happen? Nothing. Yeah.
Also, why would you have the ranges, the minimum minus the maximum, so there's the other way around?
Oh, yep. That's just me having a moment with the trying to code too fast is really what it is. Do I need to do a 1 on there as well? I don't know. I'm not worried about that right now. I'm more worried about the method stuff. But yeah, if I run this right now, absolutely nothing's going to happen. I haven't called this method. I haven't printed anything, right? So in order to really test this out, I need to both print something and then call this method, random number in range, and then we'll say 5 and 10. All right. Hopefully now I see random numbers between 5 and 10, and honestly, let's do more than just one because let's print out 10 of them, right? Get the indentation correct there. Just want to make sure this is doing somewhat properly. It doesn't look like I got 10, does it? It looks like it's not super inclusive. I think I might need to do a +1 here to get 10s. Or am I just getting really bad random draws? Oh, there we go. Yeah, no, it's working. Yeah. Not worried about the math, more worried about the method calling at this point. The nice thing about this is, never have to worry about random numbers again anymore. We can plug in any values we want and it'll work for us just fine. Wow, 2 100s. You go buy a lottery ticket after this. Go down to the casino. All right, a couple other kind of loose ends that I want to tie up with the time that we have left for today. First off, this return statement is actually doing two things. It's actually doing two things. One of the things we've already been talking about quite a lot. It's saying this is the answer, this is the result, this is the output. But this statement has a second function, which is it says stop. I'm done. Get me out of here, right? So what does that mean? That means if I come here and I try to keep doing stuff, right? After this return statement, you can see Eclipse immediately says, what's going on here? If I hover over this, it says unreachable code. It literally means I'm never going to do this line because you're telling me to stop right here. You're saying the method is over. Return means I'm done. This method is over. Go back to where you came from. So no sense in putting stuff after this return statement. However, consider that while I haven't used many of them today, we do have a thing called if statements. So doing something like this is definitely a common thing that we can do, right? If some condition happens, then get the heck out of here. I don't want this method to run, right? It's not set up right. There's an error. I don't know what, right? Just not going to happen here. And then I can go on and do other stuff down here if I need to. So that can definitely happen. Consider a case when return statements will probably not be used. Right? Be careful about this situation. What if I say something like this? How many times is this loop going to run? One time. One time. Because the first time through the loop, it's just going to say, oh, return? All right, I'm done. Method's over. Let's get out of here. So using a return statement inside of a loop, not so great of an idea unless it looks something like this. In which case, we're back into potentially good idea territory again, right? That's not necessarily a bad thing to do. You got to be careful about that, though, because a return statement quite literally stops the method in its tracks. Another thing to keep in mind, everything we've seen so far just has the one, but I'm not limited to that, right? If I want to return something in one place and return something different somewhere else, okay. It's totally fine. Think about this in terms of math, right? If I'm trying to compute, something involving division and I notice there's a 0 in there, I might check for that and give you a different answer. Say, well, 0, that's weird. That's not a number. That's some weird territory. Otherwise, I'll just give you the straight result. That's a very common path that you'll see. And then one other perhaps final thing about return statements. I've been using them exclusively in methods that have a return type. So if it has an int, and that's required, by the way. If this is anything other than void, you have to have a return statement in this method somewhere. You have to say, this is the output. I can't just not give you an int. I have to give you an int, right? However, if it is void, I can still return. I'm not giving you an output, I'm just saying we're done here, we're out. So I'm using it for that second function, not the first function. So return statements can still exist in void methods. If I see a return statement in a void method, it just means stop, we are done. If I see a return statement in a method that is not void, then that's typically going to tell me what the answer is. Tell me, what the answer is. Yeah. And I'm going to wrap up with one final example today, which I'm actually going to write out from scratch for this one. I'm going to leave you with this idea. Oops. Let's say I've got a few methods. I'll be able to make them very quick. I'll call this one A. Oh, I forgot the return type. Sorry about that. B. All right, so here I've got three methods. And the other thing that I want to do in each of these is just, I'm going to put in a print statement just to be like, hey, this is where I'm at. Just kind of saying, hey, I made it to A, I made it to B. Oops. Or I made it to C. And what I want to leave you with is this idea that every method call that I've been doing from today has started from main. So I would say, go do the thing in A. And then I come back to main once A is done. And then I go somewhere else, and then I come back to main. But it doesn't have to be that way. I might go to A, and then A might say, go to B. And then I might get to B, and B might say, go do C. And then after I print out B, it might say, go do C again. Right? Why the heck not? So, you know, what's going to happen? It's gonna start jumping all over the place. But we've talked about that flow. We've talked about that flow, and hopefully you'll get used to how to kind of decipher things in the code when this happens. I'll jump up to A first, then I'll jump down to B, then I'll jump over to C, then I'll jump back to B, then I'll jump over to C again. Right? Actually, let me run this through in the debugger. This will be our last one for today, I think. So here I am on my main method, the first line for today. I'm going to jump up to A. I'm going to say, hey, here I am in A. I'm going to jump down to B. Look at my stack. It says I was in main, then I went to A for a little bit. Now I'm in B. And now it's going to say, oh, jump to C, and now look at my stack. I was in main, was in A, was in B. Now I'm in C. I'm going to do the thing that C tells me to do, and then I've hit the end, which means I'm going to return. Where am I going to return to? I'm going to return to B, line 11. Okay, here I am. I do the next thing in B, and then it says, oh, hey, go to C again. So, all right, I'll go to C again and do C again, and then C is going to return. Where's C going to return? Well, it's going to return to method B. This time, though, line 13. You can see it, right? Not this one. I already did that one. This one. This one, right? It can actually keep track of these two different method calls, right? That's what the stack is for. That's what this stack is doing for us. It's leaving little breadcrumbs so that when I want to go back, I know where to go back to. And so, yeah, once that one gets done, I hop back to B. Oh, now B's over. Where am I going to go? I'm going to hop back to A. That's where I was before. Hop back to A. Oh, A is over. Where am I going to go? I'm going to hop back to main. This is another interesting thing that I'll kind of leave you with today. Main is our starting point. Main is also our ending point. We always make it back to main, and that's where we stop. Unless there's an error or something that throws us off the rails. But in a good execution, we start at main, and we also make our way back there at the end of the program. All right, everybody. I left you a lot to think about. Please do the exercises. Please come to studio, and I'll see you in the labs on Wednesday and Thursday. Have a great day.